Hello everyone, I hope you all are doing well. So today we'll start with another shape of geometry from conic section, which is hyperbola. We have already studied parabola and ellipse. Now we are going to look into hyperbola. Now the terminologies and the concepts, key concepts that we had studied in ellipse and parabola are more or less going to be similar here. So there isn't many things new that you are going to learn apart from its geometry and apart from its standard forms. So everything is going to remain same. So let's look at it. So again, the introduction part where we'll look into what is a hyperbola, how do we draw it, and what are its locus and its properties. Then we will look into the standard forms and its parametric form. After that, we'll look into what conjugate hyperbolas are. Now this is a new term. We call often hyperbolas which are vertical and horizontal are together known as conjugate hyperbolas. So we will look into that as well. Position of a point, again the same thing. Rectangular hyperbola is also another type of hyperbola which has a fixed eccentricity. We will be looking into that. And then chords and reflection property are the same as we had studied in ellipse. So without further ado, let's start. So what is a hyperbola? Hyperbola is the locus of a point that moves in such a way, again, such that the distance of any point on the hyperbola from the focus and its foot of perpendicular on the directrix remains always constant. So again, PF by PM would remain constant, and which is E. So in this case, E is always greater than 1, which is eccentricity. Now again, in case of hyperbola, there are two foci. Let's say this is our x and y axis. This is our y axis, this is our x axis. So how do our hyperbolas look like? Our hyperbolas are somewhat like this. So just to remind you, hyperbolas are not parabolas. They always come in pair and they have two directrices and two foci. So one of the focus would lie somewhere here, which we generally represent as AE, 0, and the other one is F2 here. This is one of the directrix and this is another directrix. And let's say if I take any point P, x, y here. So its distance from F and its foot of perpendicular here M. This distance by this distance always remains constant, which is E. Now if you remember, for parabola we had studied that PF is always equal to PM, and in parabola, since there is just one focus, so it doesn't make much difference. However, in ellipse we had studied that PF1 plus PF2 is always constant, which is equal to 2a. So here there is a slight difference. PF1 minus PF2 is always equals to constant. And now we take the mod of this, because of course we do not know which distance is bigger or smaller. And this constant here is nothing but 2a. So PF1 minus PF2, this distance always remains constant, which is 2a. Now in this case, what is our a? A is this distance. So that is how a hyperbola is made. I'll take it to the next slide and draw a hyperbola and show you the different terminologies here. So this is our, let's say, x and y axis. This is our hyperbola. These are our directrices. So this one, directrix. Here we have our focus F1. Here we have our another focus F2. This axis is now not the major axis. This is known as the transverse axis. And this axis is known as our conjugate axis. Again, terms which you need to remember. For example, you had seen in ellipse where there were questions asked where they had given you the value of the major axis or the minor axis. Similarly, in questions of hyperbola, they will give you the values of transverse axis and conjugate axis. And using that, you have to find out the rest of the things. So now you might be asking that transverse axis is taken in use, of course, this length. However, I'm sorry, this length was 2a. So this length is 2a. Now what about the conjugate axis? Still there isn't any interaction with the curve of hyperbola with the conjugate axis. Still we assume that this is our imaginary intersection up till b, and b is our conjugate value, and here also a is always considered to be greater than b. So that is how we find out what our hyperbolas are, and the rest of the things are same as to what we had studied in ellipse. If there is a line that cuts the hyperbola at two different points, then this is known as a chord, and if that chord passes through the focus and if it is perpendicular to the transverse axis, this is called latus rectum, again an important term for hyperbola as well. Now this, since this is chord perpendicular to transverse axis, is nothing but our double ordinate, and any chord that passes through the focus is known as our focal chord. And also one more thing that, let's look at it here, PF and PF2, these two distances are known as focal distances. Focal distances. So again, an important thing, you must remember this expression, and that the axes are called transverse axis and conjugate axis. The rest of the things are same as to what we had studied in ellipse. So now let's look into the standard forms.